BITE2 is a high current battery tester. It's designed to test large flooded batteries like those found in substations. As the capacity of a lead-acid battery increases, so does the active surface area of the plates within the battery. More surface area means more capacity and more current capability. As the plate size increases, the internal impedance of the battery drops. Large flooded batteries can have very low impedance values. In order to test these batteries, you must use a test set that tests with high current. So let's think about this for a minute. When trying to measure a low resistance value, do you use a multimeter or a low resistance ohm meter? You use a low resistance ohm meter because it has a higher resolution. The reason it has a higher resolution is because it tests with higher current. The same is true when testing large batteries. If you test them with a small meter that tests with limited current, you'll not have the resolution you need to see the chemical changes within the battery. This means the batteries may not work when you need them to. In addition, we need to measure the intercell connections, or the straps. These will be in the low microohms. You cannot test these with a meter that tests with 100 milliamps of current. You'll not be able to identify failing straps. As strap resistance changes, the voltage drop across them changes. This leads to unbalanced battery strings. A battery can be a source or a load. If this battery has a higher voltage than the one next to it, where does the current flow? Your string is only as good as the worst battery in that string. The BITE2 tests with 10 amps of test current. This allows you to test both large flooded batteries and the intercell connections with one single pass through the string. The BITE2 is a two-part instrument. A transmitter is connected across the entire string. The transmitter will then inject 10 amps of test current through the entire string. A separate lightweight receiver pistol is then used to take both the battery and intercell or strap measurements. There are several advantages to injecting current through the entire string. It is a direct test of string continuity. If I cannot get current through the string, I immediately know I have an open in my string. If I use a low resistance ohm meter to measure the intercell connections or straps, I'll be using a 4-pin Kelvin type lead. This means 2 pins will inject current through the strap and 2 pins will measure the voltage drop. The problem with this type of measurement is the distance between the pins. In order to achieve a constant current density, I need a minimum distance of approximately 3 times the width of the bar that I'm measuring. I do not have this with this type of lead. This means I will not have a uniform current density when I make this measurement. The value I measure will be a relative value, so I must compare the results I get today to previous results to see how much they've changed. If I were to use another probe set where the distance between the pins is different, then I will get a different measurement. Since the BITE2 injects current through the entire string, there is uniform current density throughout the string. This means my measurements will be absolute, so I can just review the values. I do not need to compare them to previous ones. To start testing with the BITE2, we'll first turn on the receiver. As it boots up, it will display its firmware version, some copyright information, the date and time, as well as the available memory. And now it'll ask us if we want to use a wand or barcode scanner. If you are testing multiple strings each day, you may want to put a barcode on the string. You can then connect a barcode reader to the BITE2 and scan the battery string. And you can see it's now waiting for a location ID. And you can see now substation 12 is on here. So it now has the ID in there. And if I pull the trigger, I can even input an ambient temperature if I want. And I can even put in pilot temperatures if I want. And now we can disconnect the wand and move on. Now we can enter a reference baseline value and alarms if we choose. The BITE2 will then indicate which cells pass and which fail. The other option is we can transfer the data to our PowerDB software. This software will automatically calculate the baseline value for each string and analyze the data. So for the purpose of this test, I will select No. I can now select a split strap. This is applicable to high current strings. The receiver uses a CT to measure the test current going through the string. If you have parallel straps in your string that the test current can be split, then this setting puts a multiplier in the receiver to compensate for this. The string I'm testing only has one path for current, so I will select No. The last thing I am asked is if I wish to measure terminal impedance. This is the value from the charger lead to the first terminal. This is sometimes required for standards testing. I am going to select No. I can now save the settings and start my test. The receiver now prompts me to connect the CT. This will allow me to measure the ripple current in the string. If the ripple current exceeds about 5 amps per 100 amp hour capacity of the battery, then this is a problem. It's typically a sign of a bad rectifier of the charger. In this case, we can see I have no ripple current, so I'll pull the trigger to save the reading. The receiver now prompts me to connect and power up the transmitter. So we connect the output lead to the transmitter. Now the transmitter can be connected across up to 275 volts DC. If the string voltage exceeds this, simply connect the transmitter across half the string at a time. We connect the transmitter across the string and turn it on, and also turn on the output. The internal coupling capacitor charges, then I get an output current. If I did not get an output current, this would be an indication of an open in the string. I can see the test current on my receiver, so I pull the trigger to save the value. The receiver now prompts me to measure the first battery, cell 1. So to measure the first cell, I'm going to first connect the potential probe. I place the receiver across the battery, and I can see the battery voltage and impedance on the display. I now pull and release the trigger to save the value. Note, the actual value is saved when the trigger is released. The receiver now prompts me to measure the first strap. I place the receiver across the strap, and I can see the impedance on the display. Again, I pull and release the trigger to save the value. The receiver now prompts me to measure the second battery, cell 2. I just complete this process until I'm done. You can see the process is easy. You only move one probe at a time. This makes it far less likely of making a mistake, especially when you're testing long strings. The more probes you have to move, the more likely it is to make a mistake. Now, for the purpose of this demonstration, I'm just going to measure 4 cells. Now, when testing a string, there's always one less strap than cell. The BITE2 saves these values in cell strap combinations. So when we reach the last cell, we need to take a dummy strap measurement. Simply touch the probes together and then pull the trigger to save the measurement. We're now done with the testing. So we just measured the last battery in our string, and now we want to look at the recorded string data. So we push the down button. Notice the receiver asks if we want to close the test. Select No. Let's not close it yet. Let's first connect the receiver to the transmitter's printer and review the data. Okay, so I'm going to first turn off the current, and now let's hook up the printer cable. So I'll hook it up to the transmitter, and we're going to hook it up to the receiver. Now you notice the receiver automatically knows it's hooked up and asks, do I want to transmit data? I'm going to say yes. Now it asks me, is the test complete? I'm going to say no, it's not complete. And it asks me, do I want to transmit to a PC or a printer? I'm going to say printer. It asks me, do I want to print all the tests or select one? I want to select a test. And I want to select the last test I did. Test 4. So we're going to go accept. And we can see we have a printout here. So now that we have printed the data, I'm only getting text values at this point. But this allows me to see if I have any questionable values. So if I do have questionable values, I can retake the measurement. Okay, so I'm going to disconnect him. And now what I can do is select the up key to scroll back to the measurement I want to take. So perhaps I want to retake cell 4. So now I'm at cell 4, and now I just pull the trigger, and I can retake the measurement. Okay, so now I'm going to reconnect the CT, and turn the transmitter back on. So now I'm going to retake cell 4. Now remember, the BITE2 saves data in a cell strap combination. So I got to take both the cell and the strap. So here's my cell measurement right now. And now I'm going to go and take the strap measurement. Okay, so I've retaken my cell measurement. So now I'm going to just press the down arrow to go back to the end of the test. Okay. I press one more, and it asks me, is the test complete? And now I can say, yes, it is complete because I know all my readings are good. Yes. Are you sure? Yes. Now we can no longer change the recorded data in the receiver. So let's connect it to the printer and print it again. So I have it hooked back up to the transmitter, and you can see it automatically knows it's ready to transmit data. So I'm going to go transmit. I'm going to select printer. I'm going to select my test. And I'm going to go back to test 4 to do it. It's actually on test 4. And I'm going to go accept. Now we're printing the data. Now we see that we not only get text data, but we also get a graphical chart as well. Now this is an easy method to see if we have any batteries that may be an issue. We see that all the battery impedances here are very close to each other. If we saw a battery that was over 30%, then that would be a sign we may have a problem. We want to investigate this. This is also needed if you're not allowed due to IT restrictions to put software on your PC. With the BITE2, you do not need to use PC software if you're not allowed. However, if you can, we do offer a very powerful analytical software for your battery analysis. In this particular case, I want to transfer my battery string data to my PC. So in this case, since I'm still on site, I'm going to pull out my Surface Pro and open my PowerDB software. So I have my PowerDB software open. I'm going to select the BITE2. And I'm going to select my COM port for the BITE. And it also asks me to select the COM port for the hydrometer if I'm using one and if it's a different COM port, but I'm using the same port for everything. It asks me if I want to transfer data, and I do. So now it's asking me to connect the BITE2 receiver and power it up. I have it connected already, and I'm powering it up, and you see the BITE2 sees that, knows it's ready to transmit the data. So now what I'm going to do is I'm going to say next on this, and it's waiting for the data to be transmitted. So I'm going to say, yes, transmit the data, transmit it to a PC. And again, it's asking for an eBite or PC. An eBite's an old legacy unit. So I'm going to select PC. And you can see now the data is transmitting. Now it's asking what path I want to save it to. And I'm going to save it to this path. And here's all the files that are in there. So I'm going to choose which files I want to save. And I'm just going to save that last file. Now I can select an owner, which I'm going to put in as Megger. I can select a region, Valley Forge. I can select substation, and I'll select the string. Now, all these you can select and create a database based on this, or you can put in new values as well, create new databases. And we'll go next. And we can see we've imported all the data successfully. To open a data file on PowerDB, go to the Home tab and click on Open. You can now select the string that you wish to view and click on that and select Open. Now you'll see all the data files under that string. Select the desired data file and click Open. And now the report will be generated. PowerDB allows you to enter a variety of data from job numbers to asset IDs to string information. To enter this information, just go to the desired field and click on that field. Some of the fields will give you selections, just choose the desired selections. Other fields, when you click on them, will bring up a keyboard. This way you can just type in whatever you like. You can also go down, and if you click on Inspection Data, it'll open up another field. This will allow you to put in any inspection data you wish. This way you keep all the data together in one report. To view cell data in PowerDB, simply scroll down the report to the cell data and you'll see the average impedance, you'll see total string voltage, as well as minimum and maximum voltage that were measured. Then you'll also see all the impedance values for each cell measured, as well as all the voltage values for each cell measured. And you'll also see the time at which each measurement was taken. To view intercell or strap data, go to page 2 and then scroll down. Following the cell data, you'll come to the strap data. Here you can view the average strap resistance, which is used for a reference during the strap analysis. You'll also see the resistance value for each strap measurement. This can be viewed in either microohms or milliohms. You can also select a type of strap, intercell, intertier. There are many choices. Only intercell straps are used as part of the strap average. This is so long straps do not skew the average. You can also right-click on the strap variation value and exclude the strap reading from the average. This ensures that no outlying strap measurements will skew the average. To enter a baseline value, there are several ways this can be done. If I already know the baseline value that I wish to use, then I can click on the cell number. I can then click on the manufacturer and enter a manufacturer's name, or I can click on the field and select from a list of manufacturers. I can then click on the cell model field and select from a list of cells, or click on cell model, and I can then enter a new cell, and this is where I can enter the baseline value that I wish to use, as well as various limits. When complete, click OK. Then just click on Use Database Baseline to use this baseline value. Now, if I don't know the baseline value, then I simply click on Use this test as baseline, and the software will automatically calculate the baseline value. The baseline value will be used as a reference value for analysis for all following tests on this string. So you're only going to need to do this once. If I have programmed a baseline value into my test equipment, I can select Use Instrument Baseline Value. The software will then use the baseline value that was programmed into the byte during testing. To set the limits, scroll down to the Limits section of the report. If you know the limits you want to use, simply click on the desired field and then enter the desired value. If you do not know what limits to set, then scroll up to the string section of the report. Now select the battery type field and select the battery type. Now scroll back down to the limits section of the report and select Use Default Limits based on battery type. All the limits will now auto-populate except for the voltage limits. These you still need to set. Consult the battery datasheet or installation guide for these values. All these limits will now be used for all the following tests of this string. To select charts to add to the report, click on the Select Charts button. This will bring up the Battery Select Charts window. You can see there's a whole host of charts to choose from. Simply check the display box to add the desired chart to the report. Now, the charts I've chosen include the impedance variation graph, which compares each cell's impedance to the string average, the impedance deviation graph, which compares each cell's impedance to the baseline, the impedance change graph, which compares each cell's impedance to its previous test impedance value, the voltage graph, so I can view the float voltage of each cell, and the strap resistance graph, which will allow me to find which straps may need attention. I can view these as bar charts or line charts. I can also choose to show the graphs within the limit lines, so I can see which cells pass and which fail. These settings can be made as the default settings, making these the default charts that will be on every report I make. When I'm done, I simply click OK. To add an image to the report, scroll down and click on the Select Charts button, then enable Diagram/Image and select OK. You can now paste the image into the report.